Welcome to 2.7, Solving Linear Inequalities. We're going to be talking about linear inequalities in one variable. Now, an inequality is one of these symbols. This is less than, greater than, less than or equal to, greater than or equal to. When you learn these in, I guess, probably elementary school, you probably learn them as alligator mouths. And the alligator mouth wants to eat the bigger number. So 8 is greater than 7, but if I had 7 on the left, it would be 7 is less than 8. Okay? Equal to just means that you are allowed to be the same thing, or you're allowed to be less than for here, or opposite here, greater than or equal to. When we talked about linear equations, we had an equal sign here. I've written this, I'm writing all of the rules using only less than, but it really could be any of these. The pattern holds no matter which of the actual inequality symbols you have. Okay, for the most part, we solve inequalities exactly the same way we solve equations. There is one difference. One thing to remember is that any time we deal with an inequality, we will be graphing and we will be shading. Every time. Every time we encounter inequalities, we will be doing some form of graphing and we will be doing some form of shading. In this case, we'll also be giving our answers in interval notation. Now, chances are you've done these linear inequalities before. You have graphed these before. You may not have done interval notation before, and you may have graphed them using a slightly different method than we use now. There's an old notation that has been phased out. Depending on when and where you went to school, you may have seen the old kind. Okay, now the thing is with inequalities is that technically, most of the time, you have infinite solutions. If I find out that x is greater than 4, there are infinite numbers greater than 4, okay? So it's infinite, but not everything, because 3 is not greater than 4, so 3 would not be part of our solution, okay? The way we do interval notation, okay, it's always going to be the left-hand boundary, the smallest part, comma, the right-hand part. The small number, then the large number, okay? And then outside of these intervals, so basically, let's say I'll use the 7 and 8 I wrote up here. So if I have a 7, and then my larger one would be an 8. Okay? So that's where, if you're looking at these examples, I have a 6 and a 9 here. Here I have a 6 involved. Here I have a 9 involved. Don't worry about which order they're in just yet. Okay. So it's always a number, and there's a comma and something. Now, we might not have an actual number as a bound. If I'm looking for numbers larger than 4, those things go up to infinity. If I'm looking for a number smaller than 4, there are infinite numbers in the other direction too. So we might have a negative infinity or a positive infinity involved. Okay? All right, so here's the rule. If we have a negative infinity or a positive infinity, you get a parentheses by it no matter what. Here's a negative infinity, positive infinity, parentheses. Now, by the number part, it depends on whether we have a less than or a greater than, in which case we use parentheses, or if we have a greater than or equal to, or less than or equal to, or greater than or equal to, we use brackets, which are the squared off ones. Okay? I'll come back to this in a second. If I'm looking for a number between 6 and 9, my number needs to be greater than 6, it's bigger than 6, it's on the big side, but it needs to be less than or equal to 9. My left-hand boundary, the smallest it's allowed to be is a 6, the largest it's allowed to be is a 9. There's a comma between them. This had simply a less than, so it gets a parentheses. This one had an equal to on it, so it gets a bracket. Okay? Here we're looking for numbers larger than 6. It's on the variable's on the big side. So it's going to be 6, and it's going to go up to infinity. It can go up as high as you can imagine. Infinities always get parentheses by them no matter what. My original problem had a less than with no equal to, so this is also parentheses. If this is not making complete sense to you just yet, don't worry about it. It will get more and more clear as we work examples. You don't have a whole lot of context for it just yet. Okay? Here, we're looking for numbers that are smaller than or equal to 9. So negative numbers are less than 9. So we start off with negative infinity. And the largest it's allowed to be is a 9. Infinities, whether negative or positive, get parentheses every time. The 9 gets a bracket because this had an equal to on it. Okay, we're going to come back to this. This is our interval notation. We will always be giving our answers in interval notation. We will also always be doing a graph. If you learned with the old notation, you may have used an open circle on your graph and a closed-in circle on your graph. We do not use this notation anymore. Okay? Where you would have used an open circle, if you learned it this way, you're going to use a parentheses. Where you would have used a closed-in circle, you're now going to use a bracket. Now we're going to come back to all of this with an example problem.